Hello and welcome to 5G Week with 4G Americas, our webinar mini-series. This is Vicki Livingston and I am the Head of Communications for 4G Americas, and I want to welcome all of you to our second mini-series webinar. We yesterday kicked off with the 5G Spectrum Requirements webinar, where we talked about the needs for both high and low frequency bands to deploy 5G technologies. And today, our focus for the webinar is on the progress of 5G technology concepts. Next slide. Today we have some really great experts to bring us some understanding. We will be moderated and receive a brief presentation from Chris Pearson, President of 4G Americas. And then our experts who will be answering questions are Michael Peeters, who is the CTO of Alcatel-Lucent Wireless Technologies, Brian Daly, Core Network and Government Regulatory Standards for AT&T, Mike Recchione from Cisco, Principal Engineer of the Mobility CTO Group, and yet another Mike Murphy, CTO North America for Nokia. We plan on having lots of questions. I know there are so many surrounding 5G, and we will be answering as many of your questions as we can. On our next slide, you can see the logos from all of our board member companies, both operators and vendors. These are the companies that form the working groups that help us to create our cohesive white papers, and we recently published a paper on the 5G spectrum requirements, which was the topic of the webinar that we did yesterday. We have also created what we call the 4G Americas 5G Hub for the latest information on the progress of 5G, and you would find that both the white paper and the 5G Hub on our 4G Americas site, and that is 4gamericas.org. Now I'd like to welcome Chris Pearson to give a brief overview. Next slide.
Thank you, Vicki, and thanks for all those out there in the wireless world that are listening to our webinar today. A good morning, good afternoon, and good evening to everybody for spending the next hour with us or so to talk about 5G and the technical concepts that are surrounding this technology. One thing I wanted to point out as kind of an introduction to it is about 4G Americas. As Vicki said, 4G Americas is a wireless industry association of 16 leading operators and vendors working together to progress the mobile broadband industry. And we focus on LTE, LTE Advanced, and their evolution to 5G. And we've been recognized around the world as a leader in the 5G space. Next slide. We have, as an organization, memorandums of understanding and liaisons with many other leading associations and organizations around the world. But more importantly, we have a very robust 5G work program. Our work program entails making recommendations on both the technical aspects of 5G, the regulatory aspects of 5G, and specifically the spectrum aspects of 5G. When we brief governments around the world, or specifically in the Americas region, oftentimes they have already read or are interested in our white paper recommendations and want further details about our recommendations. Next slide, please. So, we're here today to talk about 5G. And many of you may be saying, well, why is the time right? Well, 5G definitely has what would be considered the industry buzz right now. We see the press releases, the announcements, various things on 5G. And some people question, is this the right time to talk about it? And my answer is yes. If you look at the evolution and revolution of technology over time, it takes a long, long, long time to get it right, to make sure that there is proper standardization of technology to create the great wireless industry ecosystem that we all enjoy. So the timing is right for planning. The timing is right for collaboration. And the timing is right for cooperation. And that's why you see organizations such as 4G Americas working so diligently on the 5G space. Next slide. But let me be clear, and this is a very important point to make as we spend most of today's webinar on 5G, is that 4G Americas is very positive, very bullish, very excited about the future of LTE. Currently, as you see from the slide, LTE has 425 commercial networks in 125 countries. And of those, there's already 88 LTE advanced networks in 45 countries. The technology of LTE and LTE advanced is one of, or perhaps the fastest mobile broadband growing technology in the world. So when it comes to technology, we see LTE having an extremely bright future. In fact, LTE connections are expected to reach 1 billion in 2016 and 3 billion in 2020 when the first 5G networks are expected to be launched. Next slide. And part of that excitement about LTE and LTE Advanced and the numbers that back that up with the amount of connections is the fact that the technology roadmap for LTE and LTE Advanced has many new innovative features coming. We see that many of these features will be deployed in the next few years. Currently, if you look at LTE Advanced, the main feature that's being deployed out there is carrier aggregation. Yet if you study the actual 3GPP standard, you'll see that there are many, many awesome technical features that will help both the carriers and their customers for years to come. Next slide. So as I talk about LTE and LTE Advanced, I do recognize, or as an association we recognize, that we are in an incredible industry that is growing rapidly. And by some statistics, it's growing at about a mobile broadband demand rate of about 57% per year. So that is both a challenge and an opportunity. If you look at most industries in the world, they would love to hear that they are growing at a rate of 57% a year. And the challenge for our industry is how do we actually meet that mobile broadband demand, which will not only be about smartphones and tablets and computers, but also connecting the Internet of Things. And 5G offers the opportunity, if we get it right, to increase efficiency, increase capacity, increase adaptability, and overall increase the kind of innovation cycle of the wireless industry. Next slide. But let's be real. It's going to take time. And that's why we're here today, to make sure that everybody in this wireless ecosystem is understanding where we are and what needs to be done. You'll see from this timeline that there's a lot of work to be done on 5G. And specifically, you'll see that most of a standardized commercial rollout of 5G isn't expected to be until about 2020 or beyond. At the same time, LTE and LTE Advanced will continue to progress. And LTE and LTE Advanced will continue to basically be the mobile broadband foundation even as 5G begins to get deployed. Next slide. So yesterday we did talk about one part of 5G, and that was spectrum. If you look at how mobile operators and their vendor partners are going to serve their customers, they're only going to be able to serve them if there's both a technology evolution and revolution married to more spectrum. You'll need both in the industry for the customers to be served, both spectrum and technology evolution. So yesterday's key takeaways are, one, 5G is coming. There's no doubt that we see progress in all fronts on 5G. Two, the spectrum needs of 5G need to be addressed because it will be a key ingredient for the future of 5G. And 3, the identification of spectrum relies on the cooperation and collaboration and guidance of regulators and governments throughout the world as they look at the World Radio Conferences in 2015 and 2019. There's a lot of work to be done, and spectrum is one aspect. And we're going to cover today the technical recommendations and technical requirements and what work needs to be done in those areas. So with that, I think we're going to, I would like to say thank you, and that is the main presentation that we're having today. And most of our time, and the rest of our time, will be spent on questions and answers. So please, if you have a chance, please enter your questions, and as they pop up, we will make sure that we get them to our expert panelists. As Vicki mentioned, we have expert panelists from Alcatel-Lucent, AT&T, Cisco, and Nokia. And I'm going to begin the process of asking those questions right now. And again, look forward to seeing your questions pop up as we answer them. So the first question is for Michael Peeters of Alcatel-Lucent. We have heard about the possible new air interfaces for 5G. Can you explain this, and do you think a new air interface is going to be really needed for 5G?
Okay, so thank you, Chris. Let me spend the next hour answering that question. No, actually, let me explain briefly on why it would take at least an hour to really deeply answer that question. I think that's the important thing. And I think the basic key element we need to keep in mind here is actually what is a new air interface. And that may look like a rather basic question, but it actually, with the switch to 4G to 5G, that question isn't as simple as it's been in the past. In the past, all of the hype when we talk about the new air interface was mostly about the modulation and the coding. We had the TDMA, CDMA battles. We had the CDMA ultra mobile broadband versus OFDM battles, and so on. But for 5G, there are a bunch of much bigger changes. It's not quite the same. And there's three big domains, 3 big reasons why this new air interface is coming. First one is the one that was discussed yesterday, spectrum. While 5G will be expected to work for sure in the existing cellular bands, there's also completely new territory that we will need. And as a first example, the 15 kilohertz spacing that we're using today for the subcarriers, if you think about very high frequencies where we would have, let's say, more than 1 gigahertz of bandwidth, we would need like hundreds of thousands of subcarriers, which from a processing perspective really wouldn't make sense. And so we need better approaches there. I'm not going to go into detail because that will be covered by the other mic of Nokia at the end of this talk. So first one is spectrum. Second one is target service. If we look at the previous generations, we pretty much see that each generation had a single use case or a single service that was really targeted, and the previous generation service was a subset of that existing one. So we started with voice, then we went with 3G to multimedia, which included voice. Then we went to mobile broadband and video, which with VoLTE now includes voice and the multimedia of the past as well. But for 5G, if you've been looking at the target services, the target use cases, if you catalog them all, I think we're reaching about 100. The important thing for us is to really see that we have 4 extremes. We have the broadband, we have narrowband services, so small packets. We have very consistent services that are required, and we have very latency sensitive services. And those give you a much wider domain. So spectrum, the targeted service, and the third one is that there's a much stronger spillover between what happens in the radio domain and what happens in the core domain. Because of that heterogeneity of services, and also the existence of Wi-Fi networks and other radio access technologies like 4G, as Chris said, that will be around for quite some time to cover the broadband use case, the end-to-end capability is going to be much more important. So the new air interface is something that is going to be different than in the previous generations that transitioned. Now, is it really needed? Well, you can actually look at those 4 dimensions and see that indeed we do need a new air interface. For the ultra broadband case, while the LTE evolution will continue to serve us, it's clear that the LTE waveform is likely not suited for millimeter wave, which is more targeting very high peak rates, nomadic use cases. But we need to think about coverage and making sure that 5G can reuse 4G capacity as well. So we definitely need a new waveform to be able to span both the high and the low frequency bands, as well as having high-speed mobile broadband, which is something that people are starting to expect, that you can get mobile broadband everywhere. On the ultra-narrowband case, LTE today is not suited. Well, you can transmit small data packets and use it for the Internet of Things and machine-to-machine, but it's clear that those small data packets are not as spectrally efficient as broadband streams. So as the IoT tsunami will hit us in the coming years, that will start to decrease the average spectral efficiency of LTE, and we will need something new that can actually do small packets, both for control as well as for data, very efficiently, as well as very battery efficiently. Third one, consistency. Today we know there is a big difference between the cell edge and the cell center. If we look at some of the broadband use cases, especially in the fixed wireless local loop environment, it's clear that for example, consistent video delivery, it's not a peak that counts anymore. It's a consistent, let's say, 100 megabits per second or 50 megabits per second average. With the technology of LTE today, that's likely not doable. However, if you add in massive MIMO, those average peak rates and cell edge rate boosts are in fact possible. But that requires, for massive MIMO, a new pilot structure. You may want to make a bigger difference between different users, so there's a new user-specific control. So you need changes to the air interface again to deliver, instead of more bits, better bits, and have a monetization avenue. And then finally, on the latency side, the air interface of LTE is in fact dictating the minimum latency you can have today, even if you move your applications all the way to the edge. If we look at the Internet of Things that is today sensing, and you want to move to control, or you want to do mission critical or public safety related aspects, or vehicle-to-vehicle communication, we will need much shorter round trip times. We will need a connectionless mode, and that is again something that would be not doable to reverse engineer it on LTE. So from that perspective, in the industry there has been a lot of talk on new potential modulation schemes, coding schemes, as well as the media access and control layer. And I'm pretty sure combining that with the end-to-end core, we'll be able to define a new 5G that will gracefully incorporate the existing 4G for the broadband use case, and then build on that to offer a much wider variety of services that operators can monetize. So that's the new air interface, and that's why we need it.
Okay, great. Thank you, Michael. Next, I want to move on to a question for Brian of AT&T. We've been hearing a lot about context-aware networking as a technology concept of 5G, and I've heard, a few different explanations of it. What would be your explanation from an operator side? What does context-aware networking mean to you, and will it be important to 5G, and why?
Yeah, thank you, Chris. To put it simply, context awareness is a desired approach for a service to be context aware and to be able to provide a seamless delivery of the right set of information at the right time using the right means. Now, to understand this, we have to look to see what context means as far as mobility and network awareness. It's the availability of alternate multiple radio access technologies. It's the availability of small cells. It's the availability of macro networks. And looking at the capabilities, application, and device awareness with associated service requirements, subscription context such as operator preferences for providing service and subscriber analytics. The awareness of these attributes makes it possible for the network to dynamically adapt to the needs of devices and applications rather than have the applications adapt to today, what we have today is a one-size-fits-all set of access characteristics. What context awareness allows the network to do is adapt to the needs of the applications within the framework of the network constraints and operator policy. And that's preferable to the alternative where the applications adapt to the constraints of a one-size-fits-all set of characteristics on a default bearer, as is typical what we see in pre-5G generation of technologies. And let me give a couple of examples for that. For example, if we have IoT devices that are stationary, full mobility need not be provided to those IoT devices. We have a concept within this called mobility on demand. We tailor the mobility support for devices based upon what the anticipated lifetime mobility of those devices are going to be. 3GPP mobility management and paging doesn't need to have to be provided for services that require only device-initiated communication and resources that are configured to support long battery life, high reliability, low latency, low cost, secure communications, global roaming, and the like are only provided to those devices that are truly mobile. So optimizing the resource allocation in this manner makes possible simpler, lower-cost application-tailored devices and lower network costs because only the necessary resources are used. And it also enables a better end-user device experience.
Wow, that's great. I would say that's probably the best explanation I've heard all year about context-aware networking. Can I just follow up? Is there any possible issue with net neutrality rules when it comes to context-aware networking, or is that something that's it's too early in the process to know?
Well, I think it's too early in the process to know, but really this is not really a net neutrality issue as I see it. It's really providing the devices with the services that they need in order to support those applications that are supported on the devices. So really it's tailoring and making the network and device interactions more efficient. Okay,
great. Thanks. Moving on to another technology concept that we're hearing a lot about, and we wrote about it as well in our white paper, is really information-centric networking. So I want to turn this over to Michael of Cisco, because I know Cisco has done a lot of studying on this concept. So could you kind of talk about what is information-centric networking? Why are we hearing about it when it comes to 5G and the concept for 5G, and why would it be important?
Sure, Chris, thanks. So as Michael Peeters said, I'll talk about this over the course of the next hour, right? But really, I'll try to give a 5-minute summary or 3-minute summary, and anyone who's interested is free to contact me at michael.recchione@cisco.com for any further depth that we can't get to today. But essentially, the motivation for looking at a different way to approach transport on the internet is driven by the fact that the internet, and specifically TCP/IP, was designed to connect to static endpoints of the network. And as the internet evolved, right, mostly what we're interested in exchanging and delivering is information and content, right, to people. But we have added a bunch of other additional, say, complications to the original content, or rather concept, right? Initially, we thought of connections between static endpoints. Then we needed to overlay mobility, and the mobility overlay is cumbersome. Then we started to worry about security, and then the security overlays, both in the mobile and in the fixed internet case, are cumbersome overlays managed end-to-end. And then finally, there's the huge burgeoning of the amount of content that is delivered, and the end-to-end model of the internet just makes the amount of traffic that we have to carry, especially looking into the future, huge, right? And the overlays for that involving separate content delivery networks and caching solutions, again, are cumbersome and don't generally scale. So the motivation for information-centric networking, which is a concept that came out of the Palo Alto Research Center back in the first decade of this century, right, was what if we built the transport layer around the notions of basically delivering content and information rather than on connecting endpoints, and build into this transport layer intrinsic support for mobility so that we don't need overlays, for security where we guarantee the integrity of each data object rather than the path or the endpoints, and also build in capacity for distributed storage throughout the network so that we minimize the end-to-end storage requirements, we deliver on lower latency, right, and have intrinsic support for multi-point, multicast, and broadcast services. So that's a lot to say as an aim. How do you actually implement something like that? And the essential construct in information-centric network or networking or content-centric networking, named data networking, which are all different ways of saying the same thing essentially, are that we go from the typical TCP IP or the IP packet to, we define two types of packets on the network. One of them is called an interest packet, where some consumer or hopeful consumer of information requests that piece of information. And then we have content or data packets, which are the actual information. In ICN, only interest packets are routed, which greatly simplifies the routing mechanisms on the internet backbone and even over the air, right? The pieces of data or content have their own unique names, variable length content names, and these content names uniquely identify a piece of data rather than where to find it someplace, right? These pieces of data are stored. This is one big difference between information-centric networking and TCP/IP or IP networking is that each forwarding engine in an information-centric network is stateful in the sense that it caches and remembers content that was requested and forwarded to it, right? So each node in the network becomes a mini cache that can be accessed not only for the purpose of retransmitting to the original requester of that information so that you can shorten latency and reduce traffic and reduce congestion on a more local basis than you do in the end-to-end model in current internet, but you also have that content available for other users to request as they need it and to be able to forward it to them from somewhere in the network that's much closer to them than the endpoint server would be. So you can probably see from this that it obviates the necessity for an overlaid content delivery network. Now, the way security is enhanced in this model is that rather than securing the pathway or the endpoints of a connection, right, each data packet or each content packet is individually signed by the originator of that packet, which allows the consumer of that to verify the source and authenticity of that content, even though it's coming from a local source. As a matter of fact, it doesn't matter where it's coming from. The original source of that content has disseminated it just through the mechanisms that I sort of hand-waved and described a minute ago, right? So that content is now stored securely at all of the intermediate nodes in the network and its integrity is verifiable, right? The final point that I'd like to make about information-centric networking is the intrinsic support for mobility that it offers. In IP, each connection is a one-to-one kind of a concept. In information-centric networking, the interest packets or requests for information can come by any path, right? And so if a piece of content is stored on a node, and I'm a device that is connected in 1 minute on licensed spectrum through a service provider, and in another minute I'm coming through an enterprise Wi-Fi system, as long as I'm entitled to that content, it doesn't matter. I don't have the concept of needing to preserve my IP address anymore. All I need to do is to be entitled to that content, and a copy of that content will be sent to me in response to my interest. Right. The other thing that this enables is, because content is persistent in each of these nodes, right, there's this intrinsic support for multicasting and broadcasting, because as a piece of popular content gets disseminated through these mechanisms through the system and is persistent in each node, various requesters can request that content packet and have it forwarded to them from a node very close to them. So you can think of each node in the network becoming its own mini CDN that's capable of supporting multicast and broadcast services, regardless of the, say, originating IP address. Right. So that's essentially ICN in almost criminally short nutshell. But anybody that's interested in further, well,
it sounds like we need a webinar specific to ICN. It has enough complexity and technical aspects of it, doesn't it?
Yeah, it is.
All right, great. Well, thank you for that answer. I mean, I know it's a very complex subject matter, but one that, again, is arising in the 5G discussions quite a bit. So yesterday was kind of interesting. All the panelists know that we had a spectrum recommendations webinar from 4G Americas, and a lot of that discussion was about low, mid, and high bands, but a lot of it focused even on the high bands, because recently CTEL came up with their recommendations for studies on it and so forth. But what I wanted to ask Mike Murphy of Nokia, what will be the biggest technical challenge or challenges with the utilization of the higher frequencies? What technical challenges are going to need to be overcome for a 5G deployment using higher frequencies? Could you kind of talk about this technology concept, since we've been hearing so much about the higher bands?
Sure, Chris, and I think it's a great question. It's a good follow-up to Michael's from Alcatel-Lucent on the air interfaces as well. So in general, using very high frequencies has both technical and deployment hurdles, but honestly, I do believe they'll get resolved, and the work to do that is progressing positively. And for the higher frequencies, as you mentioned, here at least I'm mainly talking about the 30 to 100 gigahertz range or millimeter wave bands. And unfortunately, they have poor propagation, penetration, diffraction characteristics compared to what we can get with cellular today. So what that means practically is that we need techniques to overcome those limitations, and in practice that translates into technical solutions like massive MIMO and beamforming. Both of these are still in research with good proof of concept systems to show that the problem is solvable, but the challenge now really is to create practical, cost-effective, implementable products. And that's going to take some time, both because we need the chipset suppliers to produce components that are cost-effective, and for the R&D teams to make use of them. But there's a tight relationship between the technical challenge and the deployment challenge. And so in millimeter wave in general, it has problems with blockage, for example, if there's foliage like trees between base stations and the user device, or even worse, if there's like a window or a wall in the signal path. So that means we need line of sight or near line of sight between the two. And if you can't do that, then the device needs to be able to see or get connected to more than one base station to make sure it doesn't lose connectivity. And on top of that, we have cells today of several miles or kilometers in size, and in the millimeter range, we're looking more in the 100 to 200 meters or yards, and that means a lot more base stations. And then the question is, so where do you put them? Basically, for small cells in general, the view is that you put small cells on poles or the sides of buildings, and that approach has proven fairly difficult even in LTE today. So we need to find ways to make that cost effective as well. So there's a lot of challenges, but I think we're going to solve them. The technical hurdles moving from viability to implementation and the deployment issues for large numbers of small cells that we might see in 5G have to be worked out in 4G anyhow, and those are starting to get resolved. So at the end of the day, I'm confident all this will work out in 5G, and we'll see these get solved over time.
Great. Well, thank you. It sounds like a lot of challenges, a lot of research, but the progress is being made, and we do have targets, obviously, of 2020 and beyond, so should be interesting work. Let me move to, we have a lot of questions coming in, which is a great thing, and so I'm going to try to get to as many questions as I can. I'm going to direct this one to Brian of AT&T. It's someone in the audience would like to hear more about the concept of self-supporting networks and hear a bit more about how maybe NFV is going to be utilized to support the network in a kind of a dynamic and instant way. There's been a lot, the questioner is asking about, there's been a lot about NFV, but there's also a lot about self-supporting networks included with NFV. Is there any comment that you might have about the importance of NFV in 4G and 5G and about how NFV would be supporting self-supporting networks?
Yeah, thanks, Chris, and thank you for the question. Let's take a step back and make sure everyone's fully on board with what NFV is. Network function virtualization is going to virtualize network applications and network functions, such as those that are provided today by dedicated core network components, media servers, and management functions. Virtualization will enable these functions to run on hypervisors using shared off-the-shelf data center computing infrastructure. So we're taking these dedicated core components and running them in a virtualized environment on shared hardware, off-the-shelf data-centric infrastructure. We're already employing NFV in 4G implementations. It's something that's not, a 5G specific topic. However, when we get to 5G and looking at the evolution of the core, it's going to be commonplace to see, a virtualized network within the 5G core. 5G itself, we've done a lot of discussion about the radio aspects and the need for new radio access technologies for the new spectrum. But 5G is much broader than that. It's going to be looking at the end-to-end ecosystem. So we have the opportunity to look at the core network, look at some of the capabilities that are in the core today and how we can implement those in a more efficient manner as we move forward into 5G. And certainly virtualization is one component of that. Now, we're going to be exploiting as a technology fundamental to the design of 5G. NFV will be a fundamental to the design. We expect the majority of wireless networks and network functions in the RAN and the core to be virtualized, and that will increase the flexibility to meet the varied demands on control and data processing from a large variety of applications. NFV and the major principles of software design networks, such as the separation of control and data plane, network abstraction, programmability of the network by external applications, all of these should be broadly applicable to the 5G wireless networks. And this is going to enable new services, reduce the time and effort needed to implement those services, and also reduce network costs. NFV is going to bring the ability to rapidly establish network resources based on application demands and operator policy, resulting in many benefits. For example, rather than manually configuring fixed resources on dedicated hardware, which may not match to the dynamically changing application demands, operators can shift bearer plane assets as needed and allocate to users only those resources needed to satisfy device and application requirements. Again, going back to the context awareness we spoke about earlier. And this is going to better enable network operators to better utilize their network assets and quickly and more easily roll out new end user services.
Great, super. I mean, that's sounds like obviously important both to the 4G side and also to 5G. So it's really a combination, it looks like. Next question from someone in our audience, and I'm gonna actually send this to Michael of Alcatel-Lucent, because obviously Alcatel-Lucent's out talking to many operators about many things right now. It says, the question is, how should mobile operators effectively plan for 5G as they are still deploying and early in generating return on investment on their 4G investments? So the question is for you, Michael, is how should mobile operators be planning for 5G when they're still out there getting a return on their investment and still actually buying lots of equipment that's LTE and LTE Advanced?
Okay, that is a very good question. I think something that's on many people's mind, especially considering, I mean, as everybody on the calls know, 4G Americas includes all of Latin America, where indeed that question is popping up more often as operators are just at the beginning of rolling out 4G, while in North America we're actually at a peak and there's a gigantic amount of subscribers already on 4G. And I think first way to answer that question is the big business opportunity today for 4G is broadband, and we shouldn't forget that that isn't going to change anytime soon. There are new services coming up, but the LTE and evolution of LTE and investing in LTE is something that definitely shouldn't be stopped. And this is implicit in the way that the industry has been looking at 5G, is that although there's small differences in exactly how the phasing goes, I think there's a general consensus that 5G should include multi-rap capabilities that in fact allow you to reuse the existing 4G carriers for everything which is broadband in the lower frequencies, which makes perfect sense because LTE was designed to be very efficient at the delivery of broadband, and it's in fact very hard to think about a new 5G design that would do better for that particular use case than LTE or LTE Advanced. So that's one. Right. Second thing to think about is and second way to answer that question is how do we actually approach the delivery? And you could say there's three ways to approach the delivery of 5G. One, you say, well, 5G for me is essentially something that's only going to target hotspots and high band and small cells. So it's to relieve really high peaks of ultra mobile broadband as a first step, which is great, but it actually is more, to me, sounds more like business as usual, and there's no real revenue uptick there. Second one is you can say, well, 5G is first a low band secondary and then a small cell, which means it's still focusing mostly on ultra mobile broadband, could add some additional low latency services. So there's a limited opportunity for new revenues. And from our perspective, the best way to move forward is to look at 5G really as a new 5G low band primary. So find or look at new spectrum, low band spectrum opportunities. And it doesn't have to be 100 megahertz, but a first 5G carrier in the low band that will immediately give you 5G coverage everywhere. You tie in your existing 4G, which you're continuing to invest in for your broadband technologies, and you will have the opportunity to have a wide range of services, the consistency, the latency, and the ultra-narrow band on that first 5G carrier. And as new devices come in that can use the 5G carrier, you slowly shift from 4G to 5G. In that sense, I would expect the deployment choice to be much more gradual than the shift we saw from 3G to 4G.
Great. Thank you very much. I mean, I think it's a great question because it's a question that's out there right now that operators are faced with, and obviously vendors that are working with them as well. Next question I want to send to Mike Murphy of Nokia, and it's a question that came in. It comes in and it says, in the in the context of 5G, do we really need cellular IoT or cellular Internet of Things? And also, another question kind of coupled with that from someone else is, will IoT be improved with 5G? So kind of two questions, but kind of related to IoT and 5G. So maybe Mike Murphy?
Yep, thanks, Chris. Those are excellent questions. So, you know, most IoT is not carried over cellular networks today, but with especially with some new standards activity that will come out with R13, there'll be a big jump in the ability to create cost-effective solutions for cellular for IoT. So I call it kind of a first tipping point. There's a first tipping point that comes in LT with R13. So then the question is, what happens after that? So in 5G, you know, it's somewhat famous for a low latency target and having high reliability. And generally, in an IoT context, we associate that with at least what we call a Nokia critical IoT, meaning services such as connected car or industrial control, where you would need that reliability and low latency, which is not available in LT. So yes, 5G will be another tipping point for IoT, and it will expand on what's going on already in R12 and R13.
Great. Well, thank you. And here's a question related to IoT as well, and I'm going to send this to Michael of Cisco. As everyone is aware, I have 3 mics on the panel. Mike of Cisco, the question that came in is, given that given the emerging or new access network technologies for the Internet of Things, along with unlicensed and the Wi-Fi evolution, how does the industry efficiently implement seamless mobility across this diverse access environment? Any comments, Mike from Cisco?
Yeah, sure. So I think there are 2 parts to that network, rather to that answer. One of them is kind of what I dealt with earlier in talking about ICN, right? Because ICN intrinsically supports, you know, multiple access and you know, multiple connectivity for any number of applications. But then the second piece of that really talks to what Mike Murphy was just talking about, right? Which is that, you know, we view in the case the Internet of Things in 5G as requiring the ability to seamlessly integrate technologies that are not typically thought of as 3GPP technologies. You know, as Mike pointed out, most of the IoT is not using cellular technology today, and yet we would like to have some commonalities for bringing these other non-3GPP sorts of technologies into what I'll call a pluggable access network. Right now, there's a lot of work that's being done now, much of it based on, you know, for example, TS23.335 user data convergence to harmonize authentication from access technology to a AAA interface. So now you have a common mechanism across all these technologies for authentication, and also ties into a policy framework to classify various, like LoRa technologies into specific service chains, right, which is key, right? Normally, LoRa devices, for example, don't have IP addresses, right? So there would be a gateway that proxies IPv6, for example, and then to use the virtualized packet core that I believe it was Mike Murphy, or I think it was Mike Murphy that talked about it, in network slices to be able to have a unified way to deal with all of these different technologies, and more are going to keep emerging, right? But to combine them for common authentication, common routing, you know, and et cetera, common building, et cetera. So essentially, that's the answer. Is that one of the main attributes of 5G is that it needs to be agile, and it has to be able to absorb non-3G technologies into it for IoT and whatever in a way that doesn't require them to become 3GPP technologies, but enables them to interwork in a common framework.
Great, thank you very much. Next question is actually going to go to, I'm going to answer a couple, or a quick question here I got from a couple people from the audience about the presentations. Yesterday's Spectrum presentation is available on our website, the www.4gamericas.org, in its entirety. And then today's webinar will also be available tomorrow on our website. So just wanted to answer those real quickly. So next question is regarding standardization, and I'm going to send it to Brian Daly of AT&T. And it's a kind of a two-part question because there's a couple of them that have come in. But what are the challenges ahead for 5G standardization? What are the next steps for the kind of transition and development of the standards? And at what point does what 3GPP release is expected to address 5G? So kind of all combined questions to help us, because we have quite a few questions coming in. So Brian, could you kind of talk about what needs to happen for standardization and then what 3GPP release might start addressing it?
Sure, Chris. Yeah, 5G, again, from a standards perspective, we're looking at the end-to-end ecosystem. We're looking at the air interface and new radio access types. We're looking at the core network, devices, even backhaul. So the standards efforts are going to be needed to address the entire ecosystem. And again, if we look at, what are the challenges ahead, addressing the entire ecosystem certainly is a challenge. One thing is there is no shortage of requirements, and we need to try to avoid fragmentation as we develop the standards. The requirements are defined globally in multiple fora, including 4G Americas, and we need to account for the regional differences that might come in from the different requirements. 3GPP has already started a study. It's called SMARTER, a study on new services and markets technology enablers. There's work going on in SA1. We've got a RAN workshop coming up this month, and a RAN study item will likely be kicked off after that. And SA2 architecture work is going to begin in October. But these are still all study items. It's the intention that the requirements work in ITUR, Working Party 5D, are going to complete by the end of 2017, which is a very aggressive schedule for 5D. And it's going to support the 3GPP work on the specifications under 3GPP releases 15 and 16 timeframes. If we look at it right now, 3GPP plan, and again, this is a crystal ball, not nothing's firm as of yet. It looks like a lot of the 5G work will be coming in the release 15 and 16 timelines targeting 2019 and 2020. And this is both from the core and the radio perspectives. However, you've probably seen press releases that there's deployments, slated in South Korea and Japan in 2018 and 2020 respectively. So it's possible we're going to see an earlier radio interface drop in 2018 to satisfy these very real and significant political and market objectives of Korea and Japan. But overall, I think the industry is aligned around the first standards availability in the 2020 timeframe, and that if one extrapolates out from 3GPP releases, probably puts it release 15, 16 timelines.
Okay, great. Thank you. That clarifies things very well. Next, I want to move to a question for Michael Peeters of Alcatel-Lucent. We all know that there's a lot of discussion about 5G use cases. I know the 4G Americas white papers have talked about use cases as well. How do we sort it all out? I mean, should we be prioritizing or seek industry alignment on a prioritized set of use cases, or should there be some other approach? What's your general kind of feeling about the use cases that you're seeing and what should be done, Michael, of Alcatel?
Well, as I said earlier, if you look across the excellent white paper from 4G Americas, the white paper from NGMN, the white paper for GSMA, and a bunch of others, and the work ongoing in APTIS as well, there's almost 100 use cases meanwhile. And the reality is that this is good work because it actually bounds the business opportunities very well, and it gives you a very good overview. But the fact is, if we are going to try to prioritize a list of 100 with, especially in some cases, minor differences, but critical differences between them, that's going to be very hard. So from our perspective, and I think that's starting to happen in standards a little bit, and will probably be addressed at the workshop that Brian just highlighted in September, is we now have all the use cases. Let's not get overly hung up on the use cases. Let's take a step back and see what capabilities are actually necessary that build in that flexibility that we need for operators to then use a toolbox to address the use case they specifically want. Mike Recchione called it 5G needs to be agile. For non-3G technologies, I would actually put it way wider than that. 5G needs to be agile based on a core set of capabilities that then can be pushed into different directions. And from, I would say that those four core capabilities are evolution of ultra broadband, evolution of ultra narrowband, specifically highlighting the Mike Murphy's from Nokia's point on the critical IoT and the control and latency aspects, as well as efficiency for small packets, consistency, tell edge and average speed instead of peak speed, and then on the whole, the latency for things like augmented reality and control of mission critical services. So from that perspective, I think if as an industry we can prioritize across those four and see what we need to tackle first, we'll build in the required flexibility to address the many tens of use cases that we have.
Okay, great. We're coming to the end. We just got a little bit more time, and for those questions that we're not able to get to that are coming in, we'll do our best to try to answer those individually, through emails and so forth. But let me ask Mike Murphy a question. It's a two-parter. What industry changes do you expect with 5G, and also at the same time, why are these changes going to occur? I mean, what will be the main benefit of 5G in your opinion, Mike, of Nokia?
Okay, that's a good question, Chris. So it kind of relates to many of the answers already provided. So, what's really happening in 5G? So first we try to satisfy what are kind of eternal needs, meaning, bigger, better, faster pipes. And then the second is entering new types of industries, primarily made possible through the low latency capability and the high reliability. So in that sense, and this applies to IoT and non-IoT, so in that sense, the impact on industries is that cellular will be able to be applied in places where it currently is not, due to some deficiencies. So I think that's probably the biggest impact from the cellular perspective. And then for those new industries, of course, they have a new tool set to use for their applications, whether it be factories or a connected car or whatever. So that's kind of how we see the impact of 5G on different industries.
Perfect. All right. Well, we're coming to the end of our hour, and number one, I wanted to thank Michael, Brian, Mike, and Mike for your time today as 5G experts working with 4G Americas on our webinar. It's greatly appreciated, and your answers have just been excellent to help describe the technology concepts that we're all looking at for 5G. I want to remind everybody out there that is listening today, and you can let your colleagues know as well, that this webinar will be available on our website starting tomorrow, and so you can look for the presentations as well as the re-recording of it on our website, so that will help everyone out. Also wanted to direct you to our website, which is www.4gamericas.org. That is a website that has an entire area set up to follow the 5G developments, not only in the Americas, but around the world. So again, wanted to say thank you to our panelists. Thank you to all that were participating in providing all these great questions for us, and we look forward to meeting with you around the world or talking to you on a webinar in the very near future. Thank you very much, and have a wonderful week. Thank you.